Dear all, welcome to Vidyunmana YouTube channel. This is the second lecture of the basic electronics. Here also topic is that is electrical theory. This presentation goes like this: potential difference, DC and AC voltages, waveforms and energy sources. Let us start from the potential difference. The ability of a charged particle to do work is called an electric potential. The electric potential difference is the difference in electric potential between the final and the initial location when work is done upon a charge to change its potential energy. The volt is the unit of potential difference named after the scientist Alessandro Volta. He had worked for this. So it is also referred to as the voltage. The SI unit of work is the joule with unit symbol J. The SI unit of force is the Newton with unit symbol N, and the SI unit for distance is the meter with unit symbol M. Therefore, 1 volt equals to 1 joule per coulomb, hence work equals to force into distance. Next, the constant voltage is called a direct current voltage, and a voltage that varies continuously with time is called an AC voltage. The voltage source, such as battery or solar cell, provides a constant DC voltage, for example, 12 volt DC supply. Next is a voltage source, such as an alternator or generator, provides an alternating AC voltage, for example, is the 240 volt AC. So next is the AC waveforms. So many of the waveforms you might have heard. The alternating current is the current that changes direction cyclically, passing first in one direction, then in the other through a circuit. So therefore, the AC currents are produced by generators and other such voltage sources. There are two types: AC currents as well as AC voltages. Currents are generated by the current generator and voltages are generated by the voltage sources. So example for this AC source is the commercial AC power system that supplies energy to your home. Next year, so many times you might have heard about sine wave, sinusoidal waveform. So what is this waveform? The variation of an AC voltage or an AC current over time is called a waveform. The AC supplies are designated by lowercase letter here, that is V of t for voltage and I of t for current. Here t indicates the time because these two voltage as well as current are varying with time continuously. So next is here, most commonly applying waveform to any circuit is the sine wave. So the sine wave or sinusoidal AC waveform is the voltage and current waveform shape at the wall socket outlets in your home. So this is an example for real-time example of the sine wave. This figure, it illustrates the sine wave. Imagine that positive means positive half cycle. Zero is this line. Okay, this line indicates the zero level, and this bottom part is the negative half cycle. So it starts from at zero level. Okay, it reaches its maximum value, that is called A maximum. A means amplitude, and again it starts decreasing. So it reaches again zero level, and here crossover is taking place. So this is towards its negative half cycle, and it reaches its negative half cycle's maximum value. That means minus A max. Again, it is reaching to its original zero position. Therefore, here, one complete variation between the same points on the waveform is referred to as a cycle. That means starting from here to here and here. So this one to this point is called one cycle. Since the waveform repeats itself at regular intervals over time, it is called a periodic waveform. So in depth, we shall discuss this one. This is the sine wave represented by A of t equals to AM sine omega t. Here M is its amplitude. A of t means this is the AC amplitude. It varies continuously with respect to time. Okay. Most commonly it is the voltage. Let us consider its amplitude maximum. A max is +1, A minimum is minus A max is -1. This is the zero level. And here, the sinusoidal waveform reaches its maximum amplitude, that is +A max, minimum is -A max, and not minimum, that is the negative side maximum amplitude, that is -A max. And this waveform, it touches the zero line, this one, at the angle 180 degree. So here even phi is also mentioning. This is for the angular frequency, or this is called the angular notation. And next here, once again, it touches the degree 360 degree. Okay, that is the at the end of the negative half cycle. See here, this is the 2 phi. Okay, because phi to 2 phi. So from 0 to 2 phi, the total angle in degrees 360 degree. And the complete this cycle is named as time period or periodic time. It is represented with T. And here, that is the distance or the some here amplitude from its negative peak value, means from here to its positive peak value is called peak to peak amplitude. It may be voltage or current. It is represented here A peak to peak. Now here, first one, let us check this one. F equals to 1 by T. T is the time period. Therefore, frequency equals to 1 by T, means frequency here is equals to 1 hour time period. That means frequency is inversely proportional to the time period. Its unit is hertz. Next one, omega equals to 2 pi f is there. Omega is the angular frequency. Okay, that's equals to 2 pi f. Unit is radians per second. To measure all these types of voltages and current, we need RMS value. Therefore, amplitude in root mean square value, that's equals to A maximum amplitude divided by square root of 2. That's equals to 0.70 times V max. Similarly, average amplitude value equals to 2 times A max divided by 5. That's equals to 0.637 V max. Two other formulas also given for the form factor. That's equals to 5 divided by 2 into square root of 2. Value equals to 1.11. Crest factor equals to square root of 2. That's equals to 1.414. Thank you all.